Okay, and then Raven, can you share? I need to stop sharing. And then Raven, can you share your screen with the next question? Okay, so which of the following? So here there is a word here about okay, there is a word here. This, we will talk more about this later, but this means two things. It means having a spanning property, and it also means being linearly independent. So which of the following sets is a set that is both spanning and linearly independent? Okay, so this has to do with the following. Is it possible that the original set is redundant? Is it possible that in terms of if this original set is dependent, then that means that at least one of the members is a linear combination of the other members. So if it is dependent, it's redundant. Okay. Now, if it is dependent, then is it possible to then find a subset out of the original that is not dependent, that is independent? And that's the other way of phrasing this question. Like, can you find the smallest linearly independent subset of this set of three vectors? So this is what we do. Form an augmented matrix and row reduce it. Okay, so Raven, you're gonna need something like that linear algebra toolkit. Okay, so what you need is say columns. No, this one is not a good color. Okay, so columns -2, 5, and 2, 4, 1, and 2, 2, 6, and 4. Okay, we need the RREF, and then from the RREF, the set D with where the leading ones are, the set D that has the indices of dependent variables, we need that set. So let's go ahead.
What about the last three numbers? -6, 4, and 0.
Okay, yes, I am missing that. You're right. You are right. Where is the eraser? So I need an extra column. The last column is, no, it's not that. This is -6, 4, and 0. Okay, and I need the REF and I need D. So Raven, can you switch over? You have it there. You had it for the, yeah. So it's gonna be 3 by 4. That's right. So according to these calculations, based on the REF, here the set D contains indices 1 and 2. Okay, contains indices 1 and 2. Okay, here we go. So if I'm gonna call these vectors that are columns, I'm gonna call them, I don't know, U1, U2, U3, and U4. So the original set had 4 column vectors, and I want to select a subset of that set, okay? Then I'm gonna select a subset with these indices, which would mean that I would be selecting the first and the second. If I had 1, 3, and 4, I would have selected the first, the third, and the fourth. But the indices in D, the same indices of dependent variables, in this case they're 1 and 2, then I select column 1 and column 2. And those two columns are gonna be linearly independent,
Because when they
and their span, the span of those two columns is going to coincide with the span of the 4 columns. So they have both the linear independence property and the spanning property. Can we try that? Raven, can you, well, if you go back to...
If you answered that, you did it wrong. Capsa answered.
you answered that, you get it wrong.
Yeah, you have to answer the one that has all 4.
Which of the 4? Yeah, choose that, Raven, and see.
Yeah.
Wrong. Okay, so show.
No, you're correct. You're correct. It's just that they didn't do it right.
Where is details?
Click that. It'll tell you that you're correct, but you're wrong anyways. Sorry.
Click, Raven. Click that detail solution.
Yeah. Just scroll down to the bottom, and you'll see it says. Yeah.
Okay. Well, it was good practice. I don't know how the Teams in Microsoft Teams, I don't know that worked, but I think sharing the screen worked and accomplished. So you have a good weekend. I'm still working on grading your submissions, but you know, keep up the good work. And thank you, Raven, Aaron, Hunter, and I'm missing someone here, okay? Absolutely.
Did that work for anyone?
Just one second. So let's see.
What is the full thing?
The remote students, if you have a question, I can follow up with you by email or, okay? But it seems that you're good to go.
Okay, so